So, welcome today. We've gone to Switzerland, to the castle of Misocco, and you can see that we have a wonderful view behind us. The mountains are up there with snow on top. I'm in a nice castle ruin, several hundred years old, and I wanted to give you a little bit of information about what we've been doing this week in the Euroluna team. Now, we need to start somewhere, and the start somewhere is really, where are we? Well, we are here in Misocco, and most people these days have a GPS to tell them where they are, and a nice function for getting the machine to tell them when they want to go somewhere. Truth is, however, that we never know where we are, because it depends on where we are relative to something else. So it's always a relative condition, and we tend to forget that when we use the GPS too much. However, if we think about this in terms of the solar system, let's start from somewhere. Now let's start from the sun. And then we have this rule which says, my very efficient mother just Jupiter, better be a bit bigger, just served us 9. And then this one, the Pluto one, I should probably not put there. But nevertheless, let's keep it for a while. Now, if we start from the sun and say, where are the rest of us? It's very logical to start, as I've started here, on a plane. Because most of the planets actually are in the planetary plane, at least on an average. They tend to have done that over a long time. It's something about solar system formation, and it's something about that the equilibrium is to be in the planet plane. However, next question is, what's the directions? Defining the things on the Earth relative to the Sun is not always useful. It's more useful to use the GPS. However, if you go out in space, it's much more useful to have something relative to the Sun. And for that, some people has defined a coordinate system which have the planet plane as the plane, using the upwards axis, the z-axis, in the positive magnetic field of Earth right now. Also that has changed. And then we need to give one more axis in order to define where we are. A typical one is to say, where is the Sun relative to the Earth at summer, and that will give a direction. If this is where the Sun was, we will then get an axis, and I will try to put it a little bit like this on the way, and that is then our X and Y axis, and the Z one going up. Now, why am I talking about all that? Well, because this week we have been updating our data files for the mission of ROMIT 1, not so much ROMIT 2, and potentially ROMIT 3 going to the moon. We've been using the NASA system called Horizon, which actually gives these coordinates, and you can get them out of the system on any time you want, again with a reference time, of course. And we have done that for the next 4.5 years, for every hour for the moon and the Earth relative to the Sun, and of course for the other parameters we may need on the way. Thank you very much.